This is the tutorial for Chapter 4, Section 6, Formalizing Relations and Functions. And so the first set of directions asks us to identify the domain and range. And so the domain are the possible x values. So these are the x values for the domain, and the range are the y values. And so we have to do that for each function, then use a mapping diagram to determine whether the relations of functions. We're going to talk about that after we list what those domains are. So our domains are the x values. So we just list them 3, 5, 7, and 8. So those are the different domains. And so I'll put that in our roster notation. That's what the braces are for. The range values are the y values. And so those are 6, 7, and 9. So 7 repeats, so I don't have to rewrite that twice. I'm just listing what the different values are. And so that's why I just listed those as, in this case, the 6, 7, and 9. So now the mapping diagram works this way. We list the different domain values, and then we list the different range values, 6, 7, and 9. And then I draw a line to from the domain to the possible range values. So like 3 goes to 6, because 3, 6. 5 goes to 7. 7 goes to 7. And 8 is the domain for 9 being the range. So those are the different ordered pairs. So that's my mapping diagram. Now a function. Basically a function is when each domain has one range, and that's what we see here. So I would say yes, and I would say each domain has one range value. And that's what a function is, as long as that's the case. If I had a domain going from like 5 going to 7 and 9, then it would not be a function. So basically when we plug 3 in, we should always get the same answer, 6. When I plug 5 in, I should always get the same answer, 7. Plug 7 in, hey, I get the same answer, but that's okay. I'm always getting 7. And 8, well, I get 9 as the answer. So a function is when each domain has just one range. So on this next one, we're listing the domains again. So we have 0 and 3/10, 4/10, 3/10 again, so we don't have to list that again, and then 5/10. So that's just listing the domains. That's what they were asking for. Then the range values. The range values are the y component. So 6/10, 8/10, 7/10, and 5/10. So those are all different, so I'll list those. And that is the range. Now the mapping diagram, we start at 0 and 3/10. List 0 and 4/10, 0 and 5/10. And then I'll list the range values. I'm going to just do it in order from largest to smallest. So 6/10 there. We've got 7/10 and 8/10. And then I draw the arrow going from 3 to 6/10. So from 4/10 goes down to 8/10. And then 3/10 I have again, and that has 7/10 as an answer. And then 5/10 has 5/10. So this is not a function, and here's why, right here. See, the domain 3/10 has 2 range values, and so it's not a function. So that's what we'll say. Not a function because the domain 3/10 has 2 range values. And so that's what a function is. It's one in which each domain has just one range value. So here we're using a vertical line test to determine whether the relation's a function. So all you're going to do is pass a vertical line through the relation, through points. And so the vertical line will tell me if I have 2 points that cross. So it would not be a function, but this is a function because I don't get the vertical line to cross through more than one point. So that means that this domain has just one range, this domain has one range, this domain has one range, and this domain has one range. It does not have 2. So this is a function. A function, and the reason is the vertical line crosses the graph once, one time only. And so each of these vertical lines only cross at one time only. Same thing with this one. You see, I could cross a vertical line through, and I only get it to cross one time. So this is also a function for the same reason. A function, and the reason is for the same, the vertical line crosses the graph one time only. So let me give you an example of a graph that would not be a function. If I had a graph that looks like this, this is not a function. And so let's see why. Because if I cross a vertical line through, look, it crosses it in two spots. See, this vertical line represents a domain. This is one domain because it's only going straight up and down. The x value, there's only one x value for it, no matter what it is, and it's crossing in two spots. So this is not a function because the domain, or the vertical line has two ranges. See, it has two ranges. This vertical line, this one domain, has these two ranges, and so that's why it's not a function. So this next problem says the function wx. Now this is just a function notation. That wx just represents y. So it's just the vertical axis. It's that vertical axis. And it equals 60x, represents the words wx you can type in x minutes. How many words can you type in 9 minutes? So the function notation is nice because it allows the reader to see what you're substituting in. So this tells the reader, okay, he's putting in 9 minutes. And then you go ahead and substitute 9 in for x. And then we have 54 with a 0 at the end. So it's 540 words. And that's all we're doing in that case. So let's take a look at the next type of problem. And it says, find the range of each function for the given domain. So you see how they're giving us these domains right here. These are the possible x values, or the domains, x values. And so all we're going to do is substitute. We're going to take that function and we're going to put in -2. And I go ahead and do that work. And when I do that, I have -3 times by -2 plus 2 gives me a positive 8. And so that is a range value. So my range is, my first number is 8. And then I do the same thing with all the others. So I take -1, I put it in for x. So -3 times -1 plus 2 makes 3 plus 2 makes 5. And so my next one would be positive 5. And then I do the same thing for the others. So 3 of 0 would be 0 plus 2, which would be just 2. So then I know I have a range value of 2. And the range value for 1, well, you just substitute in. So -3 times 1 plus 2 makes -1. And so that's going to give me -1 for that domain. And the last one, the function when x is 2, and I substitute in, I get -6. -6 times by, or -6 plus 1 gives me -5. So that would be, actually it's supposed to be 2 instead of a 1, so it's going to be -4. So let's fix that real quick. And so we end up with -4 there, and those are the range values. So then they say find a reasonable domain and range for each function, then graph the relation. So it says the high school is having a pancake breakfast fundraiser. They have 3 packages of pancake mix, and that each feed 90 people. So here's our function, NP. So this is the number of people equals 90 times by P, which represents packages. So that's my function. So I'm going to use that here. NP equals 90P, and I'm going to set up my formula. So my formula goes this way. My inputs are P values, so number of packages, and then I end up getting N of P, which is the number of people being fed. And that's what we end up seeing. So we could have 0 packages. 0 packages would mean I would have 90 times by 0. And that would give me 0 people fed. 1 package would end up being 90 times by 1. That would give me 90. 2 packages would be 90 times 2, which would be 180. And the last one would be 3 packages. 3 packages would be 90 times by 3, gives me 270. Now I wouldn't go any further because they have 3 packages. That's as far as I can go. I can't do 4 packages. So I've got my information. I'm going to go ahead and graph it now. And so on this side, I'm going to write down people. That represents the N of P. And then on this axis, the x-axis, I'm going to put down P for the packages. And so I've got 3 packages, and I'm going to just space this out a little bit to make the line look a little bit different. So this is going to be one package, 2 packages, 3 packages. This would be like a half package, 1 1/2, 2 1/2, and so on. And so going up, I'm probably going to go by, let's go by 90s here. I'm going to call this one 90, and then this would be 180, this would be 270, and so on, 360. And so I go ahead and start. So I've got 0 packages when I have 0 people. 1 package, or 1 package feeds 90 people, it showed, and then 2 packages fed 180. 3 packages was 270. Now, I can draw a line. I've got continuous data because I could use a fraction of a package. I don't have to use a whole package. And so I'm not going to continue the line anything past this because I do not have a number past 3. So they say, go ahead and give the domain, a reasonableness for the domain. So the domain is a series of numbers. It goes from 0 to 3. But that's not the only numbers. It's every number in between. So I have to use an AND statement to show that. So I'm going to say 0 is going to end up being less than or equal to P, which is less than or equal to 3. And that's going to represent the domain. Now, the range values are going to end up going from 270 to 0. To show that, I start with 0, and I have N of P, so the number of people is going to end up being between 270 and 0 people. And so that would be my answer for the range value. So the range is an AND statement because I have continuous data in between. So those are the types of problems we're going to see on the homework. Good luck.